Oh, hey, didn't see you there. I'm Dylan.
And I'm Mo.
Oh, hey, I'm Nina.
And I'm Mia.
Mia, how come you never post anything on Instagram anymore? That's why you don't have that many followers.
What? That has nothing to do with it.
Bet. There's only one way to find out.
I guess.
And that's how it all began. From that point, we set out to find out if there is a significant correlation between number of posts and number of followers on Instagram.
Okay, here's the math. The first thing we needed to do was collect our data. So we opened up Instagram and went to our Explore page, which is a randomly generated page of Instagram posts. We chose a stratified sampling method, so we collected the number of posts and number of followers of every fifth Instagram account on our Explore page.
Next, we laid out our data onto a spreadsheet and it was time to do some math. We started with a regression analysis because it is the test that examines the relationship between two variables.
First, we created a scatter plot to determine if there was a linear relationship. When we looked at the plotted data, it appeared as if there could be a moderate linear correlation, so we continued on with our testing.
Next, we had to determine what the correlation coefficient was. Also known as R, this value represents how strong of a correlation there was between the variables. In order to find R, we needed to calculate the sum of X, which was the number of posts, the sum of Y, which is the number of followers, the sum of X times Y, X squared, and Y squared.
We did the math, found the values, and inserted them into the equation for R. In the end, we found that R equaled 0.5494. This number, in between 0 and 1, implies a moderate positive linear relationship. Next, we found our coefficient of determination by squaring R, which was 0.3018.
We continued testing from there. Next, we had to test whether the correlation was significant using a t-test. Our null hypothesis was rho equals 0, meaning there was no significant correlation. Our alternative hypothesis was rho is not equal to 0, meaning there was a significant correlation between the variables.
Next, at a 0.05 level of significance, we determined the critical value. Using inverse t with 58 degrees of freedom, we found that the critical value was plus or minus 2.0017. Next, to find our test statistic, we plugged in our n, r, and r squared values into our t-test equation. We got t equals 5.0072.
It was time to make the decision. Because our test statistic ended up in the shaded region, we rejected the null hypothesis. This meant that there was enough evidence to suggest a significant correlation between the number of posts and the number of followers on Instagram. The evidence suggested a positive linear relationship between number of posts and number of followers.
We decided to keep going from there and create a line of best fit. The regression line equation is y prime equals a plus b times x. We went back to our x, our y, xy, x squared, and y squared values and plugged them into the equations for a and b values.
Our equation came out as y prime equals negative 2,557.912 plus 358.262 times x. This meant that based on our model, if you had 0 posts, you were expected to have almost negative 2,558 followers. This also meant that based on our model, each time you posted, you would be expected to gain 358 followers.
This seemed a bit unrealistic, but we decided to create a residual plot. This would help us see how accurate our line of best fit was. So we wrote down all our observed number of followers for each number of posts we had. Then, we wrote our expected number of followers for each number of posts based upon a regression line equation.
Then we subtracted the expected values from the observed and were left with our residuals. When we created a plot of the residuals, it showed that most of the points were on our predicted line, meaning that most of our data was perfectly explained by the model.
To summarize our project in one sentence, the data suggested that the more you post, the more followers you will get on Instagram.
Mia, I told you that if you posted more on Instagram, you'd get more followers.
What? I had no idea.
Now you owe me a shout out on Instagram.
Hopefully I get 358 followers.
Well, based off of our model, you will.
Now we must admit some possible errors in our study. Even though our residual plot showed that our regression line was fairly accurate, it is unrealistic to say that someone is expected to have negative 2,000 something followers if they have no posts. Nor is it realistic to say that someone is expected to gain 300 something followers each time they post.
Second, we can't truly say that our sampling method was random. The Instagram Explore page is generated to show you accounts of people you may know or that are associated with accounts you've shown interest in.
And lastly, there were definitely some outliers in our data that we could have ruled out early on that could have impacted our regression line. But the good thing is that the majority of the time the observed values still matched our model.
In the future, we could expand our math. In addition to this, we could test the correlation between number of followers and number of people following on Instagram. We could also test to see the same correlation of posts and followers on other social media platforms like Twitter.
If there's a place you gotta go, I'm the one you need to know. I'm the
Math.
I'm the
Math.
I'm the math.
Yeah, Instagram is the shit. I agree. So slow. Oh! So slow.
I told you that if you posted more, you'd get more followers.